Hello and welcome once again to Captain Goodspeed Maths. I'm Joe, if you're new around here, and today we're discussing another new topic on the OCR FSMQ new spec, which is logarithms. So the learning objective today is to understand the properties of logarithms and solve questions involving them. So today we're going to introduce some logarithms, answer some questions with them, but next lesson we're going to delve into how to solve equations that involve logs. So let's get into it. So fill in the blanks. This is exactly what we did last time out with exponentials. We filled in the blanks. We said, well, x is equal to 4, y is equal to 5, a is equal to -2, and b is equal to a ninth. And why are we bringing this up again? Well, because logarithm is another word used for index or power. The logarithmic function is the inverse of the exponential function, so they're very closely related. The definition of a logarithm is, so we've got log to the base a of b is equal to c. So log base a, b equals c. So what does that mean? That's just a whole load of jibber jabber. Let's have a little look. So that is the power, that is the base, and that is the answer. So a is the base, b is the answer, c is the power. Essentially, this is saying you have to raise a to the power of c to get b, i.e. a to the c equals b. So think of it like that. So find the logarithm to base 2 of each of these numbers without a calculator. So 32, what do I raise 2 by to get to 32? Log 2, 32 equals 5, because 2 to the 5 is 32. So for 1, what do I raise 2 by to get 1? Log 2, 1 equals 0. Because 2 to the 0 is 1. Anything to the power of 0 is 1. So if you get asked, find the logarithm to base 2 of each of the numbers without a calculator, and given 1, you know it's going to be 0. That your answer is. What do I raise 2 by to get a quarter? Well, I know 2 squared is 4, and it's 1 over that, so it must be minus. So it's going to be -2. Root 2, what do I raise 2 by to get to root 2? How do I get to root 2? Well, I square root it. Well, what's the power of square rooting? Oh, it's a half, so it must be a half. There you go. It's as easy as that. So here's some graphs of logarithms then. So again, I've took a picture of the book. Unfortunately, it was quite small, so I've had to blow it up a little bit, which makes it a little bit blurry, but hopefully you can see it all right. So y equals log to the base a x is this. So you can see where a is on there. You need to learn these graphs, the exponential one as well, just in case you're asked to quote them in the exam. But the graph of y equals log a x has the same general shape for all values of the base a, where a is greater than 1. So the graph has the following properties. The curve only exists for positive values of x. The gradient is always positive, monotonically increasing function, so that means it always increases. It always increases. That's what monotonically increasing means. And that's something that you do at university, actually. So a nice little bit of a nugget of information there. If a graph is always increasing, it's called a monotonically increasing function. Similarly for negative, monotonically decreasing functions. So it crosses the x-axis at 1, 0, and it crosses through the point a, 1. Log a x is negative between 0 and 1. That's something that you need to know about logs. If you put a value of x in between 0 and 1, you'll get a negative output. Also worth noting about, you can't 0 is unidentifiable. It's negative infinity. It's an asymptote with the y-axis, this log thing, the negative y-axis, and log of 1 is always 0 as well, for reasons you can see on the graph right there. So, laws of logs. Again, there was a nice table in the textbook for laws of logarithms, so we'll go through them in a little bit. So there are a number of rules for manipulating logarithms. They're derived from the rules for manipulating In indices, these laws are true for all logarithms to any positive base. So multiplication, laws for indices, a to the x times a to the y is a to the x plus y. Law for logarithms, log xy is equal to log of x plus log of y. So you can sort of see where they're related there. The product on the left, hold on, let me underline it. So the product on the left is equal to an addition on the right. Product on the left is equal to an addition on the right. Same here. So for division, you've got xy equals x minus y, x over y equals x minus y. Powers, a to the x to the n equals anx, so log to the xn, something a little bit different here. The n drops down to the front, a little bit like differentiation. The n drops down to the front, and you get n log ax. But you just need to learn all these, and you tend to learn them through practice, to be honest. There's no real easy way of remembering them, just sort of learn them is the best way to do it. So a to the x to the 1 over n is a to the x over n. So log of the nth root of x, so if you think of that as x to the 1 over n, then the 1 over the n comes to the front just like before, and we get log a x. Logarithm of 1, so a to the 0 equals 1, so log of 1 equals 0. We talked about that before. Reciprocals, 1 over a to the x equals a to the minus x, so log of 1 over x equals log of 1 minus log of x. Remember, log of 1 is 0, so we get minus log of x. Log to its own base, a to the 1 equals a, log of a equals 1, or log to the base a of a equals 1. So there you go. Those are the laws of logs. So let's talk about some examples now. So write the following in terms of log x. So we've got log 4 plus log 3. So remember our law, adding logs, well, that's the same as the product. So let's have a little look. So that's going to be the log of 4 times 3. So therefore it's log 12, which if you put in on a calculator, it's some answer. I don't know. I don't know logs off by heart, but it'll be something. Log of 12 minus log of 3. Well, and a subtraction is a division, so it's going to be log of 12 over 3, which is log 4. Log x to the 4, the power comes to the front, so it's going to be 4 log x, and that's it. And that is it. That is basic logarithms for you. Those are the 3 most common things that'll come up. Obviously, remember all of the other log laws as well. Just to keep you going, there are some questions in the textbook which you can have a go at, or you can type in general log questions on Google, and there will be a ton with solutions as well. But learn those 7 laws there, and obviously remember the graph, some of the properties maybe of the graph as well, and remember this little sort of analogy here of what a log actually is. But those are the basics to logs. We'll be solving some equations involving logs in the next lesson. If you found it helpful, make sure you leave a like down below. If not, let me know what I can do to sort of make more sense. Remember that all of the lessons are uploaded to the Google Drive, so you can go through the lessons at your own pace. And there's also a playlist for all FSMQ lessons to make sure that you have every bit of equipment and knowledge that you need to do the exam, usually in June. So thank you very much for watching, and best of luck with your FSMQ.